नाहीये सुट्टी प्रथमेश आज. जरी एकादशी असली तरी आपण आपलं काम सुरू ठेवायला काहीच हरकत नाहीये. Okay. My screen is visible?
Yes, ma'am.
So we are discussing about VHDL programming. In that, we are discussing about basics of VHDL programming. That means how we can construct a program that we are discussing. Till now, we have not discussed how to write a program, but what are the syntaxes that we are going to use in VHDL programming that we are discussing. Okay, and so today we are going to discuss now about concurrent statements. As we already discussed that VHDL is a concurrent language. That means we can process certain functions simultaneously, or we can process or execute certain statements in parallel with each other, so that we can save a simulation time. Okay, that means at the same simulated time we can execute some statements or some processes. So now we are going to discuss about these concurrent statements. Now these concurrent statements, these pass information through signals. Okay, so these there are different concurrent statements that are defined in VHDL language. So that is process assignment statement, then concurrent signal assignment statement, conditional signal assignment statement, then selected signal assignment statement. After that, block statement, then concurrent procedure calls, and concurrent assertion statement. So these are the different types of statements that are stated in a VHDL language, which are the concurrent statements. Now, this method of stating concurrent statement that is used in data flow modeling, as the data flow modeling that describes a circuit in terms of its function and the flow of data through the circuit. So simultaneously we can execute some statements, and so here this concurrent statements that are used in a data flow modeling. Now these concurrent signal assignments that are event triggered and executed as soon as that event is on. Okay, that means that signal occurs at that instant only. These concurrent statements or concurrent signal assignments that get executed. So now one by one we will see these different types of concurrent statements. So the first, that is the process statement. Okay. Now, as we know that this process that is composed of set of sequential statements. That means we in a process we have certain statements that we execute sequentially. But if we consider different processes, then that processes are themselves are a concurrent statement. That means we can process different processes at a same time. So all the processes in a design that can execute concurrently. However, at any given time, only one sequential statement is executed with each process. Okay, that means in each process, only one sequential statement that will get executed. A process communicates with the rest of a design by reading or writing values that from that signal or to that signal, or force declare outside the process. Okay, so the syntax for this process is label. Okay, so we need to give certain label to the process that we are defining. So label colon process and then sensitivity list. That means the parameters that we are going to use here. Then process declaration part. After that, begin, and then there will be sequential statements that we are going to execute in that process, and then end of that process. Now here this label which we have given already. Now this is optional. If you want to write it here, then you can have this. But otherwise, there you can skip it. But if you are writing, you have to give the same name as that of you are giving it here. Okay, so this is the syntax for the process statement. Okay. So now this process statement, it has a process declaration part. So it defines objects that are local to the process. Okay, that means in a process declaration part, the objects that we are going to use only in that process that are declared, and it can have variable declaration, then constant declaration, then it could have type declaration, subtype declaration, then subprogram body, alias declaration, and use clause. So all of this that we have discussed in a sequential statement. Okay. So the same thing that will be present in a concurrent statement also. That means actual process declaration that will be similar to how we are defining it in a sequential statement. But the one process that we have and the another process that we have, that two can be executed simultaneously. That means that could be these two processes that could be concurrent process. So now, as we have discussed this earlier, so we will go forward and then we have one example for the process statement. Okay, so here we have the architecture of A2, okay, with the entity that is example. So here architecture A2 of example is. Now there are four signals, okay, that are I1, I2, I3 and I4. At the same time, there are two more signals that are AND underscore out or underscore out. And then all these signals, these are bit type. Okay. Now actually what this example does, or what this process does, it is calculating, or it is getting the result as a ANDing of all the four signals, that is I1, I2, I3 and I4, that will give us the output AND underscore out. Okay. So that is the ANDing of all these four signals. And also we want ORing of these four signals also. म्हणजे आपल्याला काय करायचंय की या सगळ्या सिग्नल्स जे आहेत आपल्याकडे I1, I2, I3 आणि I4 याचं अँडिंग पण करायचंय आणि आपल्याला I2 या चार सिग्नलचं आपल्याला ऑरिंग पण करायचंय. ओके. आता या दोन्ही प्रोसेसचे रिझल्ट जे आहेत ते वेगवेगळे आहेत, म्हणून आपण काय करू शकतो की हे दोन्ही जे सिग्नल्स आहेत ते आपण एकाच वेळेला कॅल्क्युलेट करू शकतो, कारण कुठल्याही आउटपुटचा रिझल्ट हा एकमेकांवरती डिपेंडंट नाहीये. So here we can have a processes that we can define process for each of the output, and then we can execute it simultaneously, or we can say it as a concurrency. So we have defined here. Now architecture begins with the begin word and then process one. Okay, so here this PR1, it is the label given to the process one. So PR1 colon process, and in that, as we are going to use all these signals, so I1, I2, I3 and I4, these are in a bracket. Okay, and then the beginning of this process, here what we are doing, we are calculating AND out. So AND out is assigned to I1 and I2 and I3 and I4. Okay, so semicolon, that means end of this statement, and then only we want to calculate this only, or we want to have this operation. So end of this process PR1 and then semicolon. So here this process will calculate or will execute the statement I1 and I2 and I3 and I4. Okay. Now we have another process, that is PR2, which is process I1 of this sensitivity parameters that are I1, I2, I3 and I4, and then beginning of this process with begin keyword or underscore out, that is assigned to I1 or I2 or I3 or I4 and then semicolon. Okay, so this is the end of process PR2, and then we have ended this architecture A2. Okay, so now what will happen here? These uh, two processes that will be executed concurrently. So remember that those statements in the process that are executed sequentially, but the processes itself are the concurrent processes. Now, moving forward to the concurrent signal assignment. How we can have a concurrent signal assignment that we will see. Okay. So, whenever we are assigning certain signals, so this concurrent signal assignment, that is the another form. It is used outside of a process, but within an architecture. Remember that these concurrent signal assignments that are not done in the process, because the process has the sequential statements only, as concurrent statements that are executed simultaneously. So it may lead to the error. So these concurrent statements that are outside of a process but within a architecture only. The syntax for this uh, concurrent signal assignment, that is a target signal which is assigned to. So for assignment, this symbol that is less than equal to, and then expression, here there will be expression, and after time expression. Okay, so here this time expression that will be given, and then end of the statement, for that we use a semicolon. Okay, now this is similar to the sequential signal assignment, but here uh, whenever we are executing this statement, this after statement that will be simulated, but when we are synthesizing this statement, this after part that is ignored by the synthesizer. So any signal on the right side of this assignment is like a sensitivity list of list elements. Okay, so that means this right side part is will act like a sensitivity element in a process. So these are certain concurrent signal assignment examples. Okay. Now all these examples that are similar. Okay. That means it will do the same function as we discussed earlier, but the way of expressing these statements, that is different. Okay. That means here also we have signals, that is I1, I2, I3 and I4, and we are going to get ANDing operation of all these signals and ORing operation of these signals. Okay, and this to AND underscore out and OR underscore out, that will be the output for these operations. Okay, so this is the first example. Here you can see the first, sorry. This is the first example, which is a very simple example in which these two statements that are assigned in an architecture only. That means there is no any process, and then these are executed concurrently. Okay, so here you can see architecture A1 of example is, and then signal assignment. So signal I1, I2, I3 and I4 and underscore out, comma, or underscore out, all these are of a bit type. Okay, and then beginning of architecture, and then we have these two statements, that is AND out, which is assigned to the result of I1 and I2 and I3 and I4. Okay, and then OR underscore out, that will be assigned to a result of I1 or I2 or I3 or I4. Okay, so and then end of A1, that is a architecture A1. Okay, then another example that here you can see This is the architecture A2, which we discussed earlier. Now here, what is the, we have defined two processes, okay, and then as we discussed earlier, here in the first process, we are calculating AND output, and in the second process, we are calculating a OR output. Okay, so now here these two processes that will be uh, executed concurrently. Okay, now here we have just two statements, but here we have two processes, and that will be executed concurrently. That means the way of stating this or having these signal assignments that we have deferred. Now here we are calculating these results in a process. Okay, then here there is one more example. Now here instead of having two examples, two processes, we have only one process, and then as the here architecture for A3, that is like we have signal assignments, required signal assignments that we have done here, and then after that in a begin we have declared one process, okay, and this process that will do this two operations, that is the ANDing operation as well as ORing operation, and after that we have one statement that is wait on I1, I2, I3 and I4. Okay, I1, I2, I3, I4, and then semicolon. So what it will do? It will wait for the another values of these signals. Okay, and then end of the process. That means if there is no any change in this signal, so whatever result that will be, we will have for all these operations. Now here these operations will be executed concurrently. So this is the another way of having a concurrent signal assignment. Now another type of signal assignment that in a concurrent statement, that is a conditional signal assignment. Okay? Now conditional signal assignment is a concurrent statement and it has only one target. But though the target is one, it can have more than one expression. Except for the final expression, each expression goes with certain conditions. That means the final expression will not have any condition, but otherwise all the expressions that we are going to state, that will have certain conditions. And these conditions are evaluated sequentially. If one condition evaluates to true, then the corresponding expression to that condition is used. Otherwise, the remaining expression is used. Again, if that is true, then corresponding expression for the that condition that is used. Otherwise, the final. If suppose all the conditions that are not true, then whatever is the final that is used for the result. Okay. Now here the syntax for this conditional signal assignment is a target. That means whatever result, whatever expression that we have, that is assigned to the expression. Then after time expression, now this is optional. So after time expression, when condition else. Okay, that means here there will be certain expression when this condition is true. This expression will be executed. Else there will be another expression after time expression, and then it may have certain another condition, and then if that condition is also not true, then it will go for the final expression. So this is the syntax for the conditional signal assignment. Now suppose in this case, now we have more number of expressions or more number of conditions that we have, and if more than one condition is true, then in that case the value of the first condition that is true, and that will be assigned. So remember that we cannot use this conditional signal assignment in a process. Okay, so we can have this in an architecture body, but we cannot use this conditional assignment, signal assignment in the process. Okay. So here there is a example of this conditional signal assignment, which are the concurrent signal assignment. So one example, that is, suppose we have four signals. Okay, signal A, B, C, and D, all are of the integers. Now, what we want to do? We want to assign A as B when value of D is greater than 10. Okay. Otherwise, if the value of D is greater than 5, then we want to assign value of C as a result. Okay, that means A will be assigned as C, and all or if both these conditions are not true, that means if the value of D is other than this, then we will have A as equal to D. Okay, so for that we are writing a statement. Okay, so now architecture A1 of example, that means this is the entity is signal A, B, C, D, colon, all are integers, so all are integer type, and then okay, so we are going to now begin this architecture. So now here A, which is the target for which we are executing these statements, so that is assigned to B. That means this is the expression when when D is greater than 10. Okay. Now else C, this is the another condition when D is greater than 5, and else it is D. That means this is the final expression that we have, and here there is no condition for the final statement. Now suppose value of D is equal to 15. Okay. Now what will be value of A then in this case? Are you getting this? My question is, if the value of D is equal to 15, as it is an integer and as it has not given any range, we can have any value for D. And I am taking, suppose, for example, value of D is equal to 15. So, how these statements will get executed? लक्षात येतंय माझं क्वेश्चन? Hello? Are you all listening to me?
येस मॅम.
माझा आवाज येतोय सगळ्यांना?
हा मॅम येतोय.
माझा क्वेश्चन समजला?
मॅम नाही, म्हणजे थोडंसं कन्फ्युजन आहे.
ओके, मी परत एकदा रिपीट करते. आपण काय करतोय? कंडिशनल सिग्नल असाइनमेंट करतो, बरोबर आहे? मग याच्यामध्ये आता काय होणार आहे की प्रत्येक आपण एखाद्या टार्गेटसाठी, म्हणजे मला ज्याची व्हॅल्यू कॅल्क्युलेट करायची आहे त्याच्यासाठी मी एक एक्सप्रेशन देईल, आणि मग ते एक्सप्रेशन कधी एक्झिक्यूट होणार आहे किंवा ते रिझल्ट कधी तसा असाइन होणार आहे, जेव्हा कुठली तरी कंडिशन फुलफिल होईल. आता इथे आपण नंबर ऑफ कंडिशन असाइन करू शकतो. ओके, पण फायनल कंडिशन जी असणार आहे त्याला मात्र, म्हणजे फायनल स्टेटमेंट जे असणार आहे किंवा असाइनमेंट असणार आहे त्याला कुठलीही कंडिशन असणार नाही. ओके, इथपर्यंत लक्षात आलंय तुमच्या? ओके, तर त्याच्यानंतर आता मी समजा मला काय करायचं आहे की मला ए ची व्हॅल्यू बी ला असाइन म्हणजे बी ची व्हॅल्यू ए ला असाइन करायची आहे कधी, जेव्हा डी ची व्हॅल्यू 10 पेक्षा जास्त आहे. ओके, नाहीतर मला काय करायचंय, सी व्हॅल्यू असाइन करायची आहे जर डी हे 5 पेक्षा ग्रेटर असेल. आणि डी ची अदरवाईज मला काय करायचंय की दुसऱ्या कुठल्याही केसमध्ये म्हणजे 5 पेक्षा लेस असेल व्हॅल्यू डी ची, तर मला ए ला असाइन करायचंय, जी काही डी ची व्हॅल्यू आहे डायरेक्टली ती असाइन करायची आहे. ठीक आहे. आता या केसमध्ये मी आधी पण सांगितलं की कुठलीही जर एकच कंडिशन तुमची एक्झिक्यूट होणार आहे, बरोबर आहे. सो here the all these conditions that will if the first condition is true then it will take that result, otherwise it will go for the second condition. ठीक आहे, त्याच्याप्रमाणे ते एक्झिक्यूट होणार आहे. आता यामध्ये या सगळ्या कंडिशन कंकरंटली चेक होतील, पण जर यातल्या मोर दॅन वन कंडिशन इज ट्रू देन जी पहिली कंडिशन आहे ती ॲज अ रिझल्ट म्हणून कन्सिडर होईल. म्हणजे तुमचा असाइनमेंट कुठला होणार आहे, ज्या पहिली कंडिशन जी ट्रू असणार आहे त्याच्यासाठी. ओके, मग मी आता काय विचारलं की जर तुमची व्हॅल्यू डी ची 15 आहे, ओके, तर काय होईल. 15 आहे म्हणजे ती डी 10 पेक्षा ग्रेटर आहे. ओके, आता 10 पेक्षा ग्रेटर आहे म्हणजे ती 5 पेक्षा पण ग्रेटर आहेच, बरोबर आहे. That means these two conditions that are true. Okay, so as all these conditions that are checked, okay, पण यातल्या दोन कंडिशन्स करेक्ट आहेत, पहिली पण करेक्ट आहे आणि दुसरी पण करेक्ट आहे. सो इट विल टेक द फर्स्ट स्टेटमेंट. ओके ओके, दॅट मीन्स वॉट एव्हर इज द कंडिशन हिअर दॅट विल बी असाइन टू ए. आणि मग त्यामुळे बी ची जी काही व्हॅल्यू असेल ती ए ला असाइन. लक्षात येतं. या कंडिशन सगळ्या कंडिशन ह्या सायमल्टेनियसली चेक होतील, पण यातल्या जी कुठली जर एकापेक्षा जास्त कंडिशन ट्रू असतील तर त्यातली जी पहिली कंडिशन असेल ती ती सिलेक्ट होईल, म्हणजे ती असाइन केली जाईल तुमच्या टार्गेटला. ओके, नाउ हिअर द सेम example we have with process statement. Okay, so here process is declared. Now here architecture of A2 of example is signal A comma B comma C D that are all are integer type, and then begin. Now here we have process statement, okay, or process that we have declared. So the sensitivity elements for this process that are B, C and D, because we are going to check for these three signals. So these are sensitivity signals, and then we are beginning with for this process. So now here in this process, as we know that we are having sequential statement in this process. So we have going to use a if statement. So if D is greater than 10, then A will be assigned to assigned value of D. Okay, else if D is greater than 5, then A will be assigned value of C, and otherwise else A will be assigned value of D, then end if, and then end of this process, and then end it. There is certain misalignment in this example. So here actually this should be end process. So here in all this slide there is certain misalignment, but तुमच्या लक्षात येत असेल की आपल्याला इथे काय स्टेटमेंट हवा आहे, एंड प्रोसेस. ओके, सो दिस इज द एंड प्रोसेस अँड देन एंड A2. ओके, so this is the about the conditional signal assignment. Now you can have a case statement also in this conditional signal assignment statement. So in that way also you can have this signal assignment. Okay, so is this clear to you?
Yes, ma'am.
Now there is again one more type of signal assignment, that is a selected signal assignment in a concurrent signal assignment or signal statement. So these selected signal assignments that are similar to the conditional one. Okay. This selected signal assignment, they can have only one target and can have only one with expression. Okay. Now this value is tested for a match in a manner similar to the case statement. That means how we are using case statement, in that way only this selected signal assignment that is done. Now the target in a signal that will receive the value of the expression whose choice includes the value of choice expression. So here, if we look at the syntax for this, it will be with choice expression. Now, uh, in a conditional statement, we have the condition afterwards, but now in this selected signal statement with choice expression, we are going to select the expressions, okay, which is the target, then which is assigned to expression, then after time expression, and then when choices, okay. So here we need to have choices, and depending on that expression that will be assigned to the target. So uh, this the expression is selected with the first matching choice. The choice can be static expression or a range expression. So while having this selected signal assignment, we need to have follow certain rules, and that is we need to remember that no two choices can overlap. Okay, and all possible values of choice expression must be covered by the set of choices unless the other choice is present. Okay, that means whatever are the possible choices that must be covered in that expression, in that statement. Otherwise there should be a choice that is other. Okay, so म्हणजे कुठलाही जर यातल्या आधीचे कुठलेही चॉईसेस जर मॅच होत नसतील तर अदर स्टेटमेंट तिथे तुम्हाला असाइन करावं लागेल. So any selected signal assignment can be described by process statement which contains a case statement. Now here, remember that you cannot use selected signal assignments in a process. Like a conditional signal assignment, you cannot have these selected signal assignments in a process also. So that you need to remember. So now we will have one example for this selected signal assignment. So again remember that both these examples that are similar. Okay. So here we have, suppose one signal that is a SEL. Okay. Then with this SEL, what we want to select Z will be assigned to the value of A when this value of SEL, that is 0, 1 or 2. Okay. It will be assigned to the B when this select is equal to 3 to 10. Okay. And otherwise it will be assigned to others. Okay. That means suppose we have 4 signals. One is the select A, B and C. Okay. So here if select has the value of, if it now this has the value that is 0, 1 or 2, then A, whatever is the value of A, that will be assigned to Z. Otherwise, if this select SEL that has the value from 3 to 10, then B will be assigned to Z, and then if in other cases it will have C value. Okay. So whenever we are executing this statement, what will it do? It will check for all these conditions for this select statement. Okay. And depending on which condition is true or which choice is, now here it is not a condition but it is a choice. So which choice is true, then from depending on that there will be assignment. Okay, so the same we can do it in a process also. So for the process we have all these sensitivity elements, and then beginning of this process, and here we have used a case test. Okay, so it will check this choice expression, that is this SES. Okay, and then whenever this SEL has the value 0, 1 or 2, it will assign Z to A. Whenever SEL has 3 in between 3 to 10, Z will be equal to B, and when in other cases Z will be having value that is C, then end of this case statement and then end process. Okay, so here you can see that all the choices now, whatever are the choices, जब select ची जी काही व्हॅल्यू असेल त्या सगळ्याच व्हॅल्यूज साठी आपण इथे स्टेटमेंट लिहिणार आहे. ओके, ते तिथे तुमचं असलंच पाहिजे. सो त्याच्यासाठी काय केलं, आपल्याला बाकीच्या कंडिशन सिलेक्टच्या व्हॅल्यू काय असणार आहे ते माहिती नाहीये, त्यामुळे या दोन व्हॅल्यू साठी आपण इथे चॉईसेस असाइन केलंय. पण या तिसऱ्यासाठी आपण काय केलं, अदर म्हणजे कुठलीही बाकीची व्हॅल्यू असेल तर आपण तिथे काय घेणार आहे, ती घेणार आहे. ओके, so in this way we are assigning selected signal assignment. Okay. After that, we are going to discuss about block statement. Okay, so now we have seen till this, we have seen how to assign signals. Now after that, we are going to see about block statement. Now what this block does? It allows the designer to logically group sections of concurrent model and sections that are not scheduled to be used in other models. Okay, that means it will allow us to logically group certain sections. Okay, which we are not going to use in a other model. Now these blocks are used to organize a set of concurrent statement hierarchy. The syntax of this block is label, then block, and then after that there will be block declarative part, then begin of this block, there will be certain concurrent statement, and then end of block. And here the label which we have given to this block, that will be present. Now whenever here whatever is in the square bracket, okay, it is a optional. So if you want to write it, you can have it, otherwise you can skip this. But if you are writing this, it should be same as that of this label. So block declarative part that defines objects that are local to that block, and it can have many number of items, okay, that we are going to discuss afterwards. So here we are declaring this block. In this block there will be block declarative part, and then after begin word there will be concurrent statement, that means the statements which are going to execute parallelly. So in a block declarative part, it defines objects that are local to that block. Okay, that means these declarative statements that will be used by only that block, that they are not available in the architecture board. So here we can have signal declaration in a block declarative part, then we can have constant declaration, we can have type declaration, subtype declaration, subprogram body, then alias declaration, use clause, then component declaration. All these declaration that we can do in a block declarative part. Now, as we have already studied about all these type of declarations, so you know how to declare signals and constants and all these. So that similar type of statement that will be present in a block declarative part. Now, these objects declared in the block are visible to that block and all the blocks that are nested within. That means again, like a function or like a process, we can have nested blocks also. So whatever declarations that you are doing in a block declarative part, that will be visible to that block, and then if any other blocks that are nested within. When child block declares an object with the same name as the parent block, uh, this child declaration that overrides the parent. That means in a nested block, so whatever is the inner block, if it has the same name, then it will be override to the main block statement. So here we have one example. Suppose we have block B1 hyphen 1 is nested with block B1. Okay. Now both B1 and B1 hyphen 1 that declare a signal name S. Okay. That means in both these blocks we have a signal which is named S, and the signal S used in the block B1 hyphen 1 will be the one declared within block B1 hyphen 1. With, while S is used in a block B2 also, which is one declared in B1. Okay. हे आपल्याकडे काय आहेत दोन ब्लॉक्स आहेत, एक तर B1 आणि B2 आहे. ओके. आता याच्या बरोबरच आपल्याकडे अजून एक ब्लॉक आहे B1 हायफन 1. ओके. हा ब्लॉक काय आहे तर तो B1 मध्ये नेस्ट केला. ओके. सो दॅट इज अ नेस्टेड ब्लॉक विदिन block B1. आता B1 and B1 hyphen 1 in both this have a signal which is named as S, but both these signals are of different types. Okay, so whatever is the signal S that will is declared in B1 hyphen 1, that will be used in B1 hyphen 1 block only. Okay. But the signal which is declared in B1 that is used in B2. Okay. So here for this, that means it will check for all these statements. So we have the architecture of this behavioral type of architecture of example. This is the entity name that is given is. Now signal out1 which is of an integer type, and signal out2 which is of a bit type. Okay, and then beginning of this architecture. So here we are having a block statement. So block B1 colon block that is has a signal S which is of a bit type. Okay, then beginning of this block, and now in this block again there is a one block that is a B1 hyphen 1 which is a block having a signal S. Now this, though the name of these two signals that is safe which is S, but here this is a integer. Okay, and then this is a begin of this block. Here out1 will be assigned to S, will be assigned value of S, and then end of this block B1 the hyphen 1. Okay, and then after that there is a end of block B1. Now after that, now here we have ended block B1, ज्याच्यामध्ये आतमध्ये एक अजून एक ब्लॉक होता की तो काय आहे की नेस्टेड ब्लॉक आहे, आणि त्या या दोन्ही ब्लॉक मध्ये एस आहे, पण ही जी व्हॅल्यू आहे ब्लॉक B1 मध्ये सिग्नल जो एस यूज केलाय तो बिट टाइप आहे, तर B1 हायफन 1 मध्ये जो ब्लॉक यूज केलाय तो काय आहे इंटीजर टाइप आहे. त्यामुळे आता जेव्हा एक्झिक्युशन होणार आहे तेव्हा या out1 ला कुठली व्हॅल्यू असाइन होणार आहे, तर ही जी एस ची इंटीजर व्हॅल्यू आहे ती असाइन होईल. ओके. आफ्टर दॅट वी हॅव अनदर ब्लॉक दॅट इज अ B2. which is again a block. So B2 colon block and then begin of this block. Here we have the assignment statement, that is out2 is assigned to value of S. Okay, and then end of this block B2. Now here, as this out2 is here, you can see that it is a bit type. That means whatever is the value that is assigned to this out2 will be the value of this signal S, which is of a bit. Okay, so and then there will be end of this behavior. So all these statements that will be executed concurrently, and this out1 that will have the value of S, which is integer type, which is assigned in the B1-1 block, and this will be of a bit type. Okay, so this is about the block statement. So here we can have these statements that can be executed concurrently. That means these blocks that can be executed concurrently. Now, coming towards the procedure call in a concurrent statement. That means we are now going to discuss about the concurrent procedure call. So this is a procedure call that is executed outside of a process. Okay, and it stands alone in an architecture. That means these whatever procedure calls that we are calling that are executed outside of a process will not have any procedure call, and they are alone in the architecture. That means they will be executed alone in a architecture. Now this concurrent procedure call has input, output, and in-out parameters. That means these in-out and in-out parameters that are available in concurrent procedure call. Then it has more than one return value, and it is considered this procedure call that are considered as a statement, and these calls is equivalent to a process containing single procedure call. So this is a example of this concurrent procedure call. Here we have this procedure that we have defined. So just a procedure that a statement that will be present here. So the procedure and that can be executed in this architecture. Okay, so these procedures that can be also executed concurrently. Then after that, we have a concurrent assertion statement. Now, what is meant by assertion statement? So, what assertion statement does? We have discussed about this assertion statement in a sequential statement also. Now, here also the same action that is performed in a concurrent assertion statement. Now, again, the same question. Why these statements are used in a sequential or concurrent assertion statement? Why these are used? कशासाठी यूज करतो आपण assertion statement? To give a error report or the warning. Okay, if we want to have a certain message that to be printed, then for that we are using assertion statement. So this statement is used for simulation purpose only. That means this will be given, this type of warning or error message that will be given in the simulation phase only, and it will be ignored by the synthesis tool. Okay, so here we have these different types of statements which we are using in a concurrent statement. Okay. Now we are going to discuss about these subprograms and other things in the next lecture. But for today, we will stop here. Okay. If you have any doubt, anyone has any doubt regarding this?